So we implemented this thing last time. So this is the output layer of a small neural net. I think like 2 layers. And then this is the output of like a larger neural net. And we are training, like we're fitting the large neural net to a random training set. And then we're fitting the small neural net to the output of the large neural net on all of the grid points here. So that's like 49 grid points. And then like the square is like a visualization of how frequently a point is not like in the grid relation to its I think all of its neighbors in the same row in the same column. That turned out to not be like all of that interesting of a visualization. Although I mean like you can kind of see like I guess you can kind of make the observation that like the first layer of the large neural net has like everything is still a grid, and also like the second layer. So it takes a number of layers, I guess, to become not gritty. But anyway, that's not what we're talking about. We want to talk about that like visually, you know, like this is a, I think it's like a 2-layer neural net. And it's pretty like visually indistinguishable from the 4-layer neural net, or like it's I mean it's not completely indistinguishable, but it's like a subtle difference. So that sort of raises the question, which is what we're doing in this video, which is like, can you find like 4-layer neural nets that that implement a mapping that is like clearly visually distinguishable from the mapping that a smaller neural net can mimic. I mean, like, it's kind of an issue of like subjective, because I mean, like, you know, this has like a weird that this doesn't have, but might also be better to do it like in 3 dimensions, but maybe I will do it in 3 dimensions. But anyway, so like the idea for this video live stream is to start with like a population of larger, say like 4-layer, 5-layer neural nets, and then like basically define the fitness, I guess, of each. So each of the larger neural nets, like every iteration, we will fit a smaller neural net to it, and then like the neural net, the larger neural net, who's like where the smaller neural nets have the most problem fitting it, you know, like will be selected and then I guess like mutated by adding some noise to the weights. And that will be like the whole thing, and then we'll see if we can like find some mappings, you know, from like R2 to R2 that a large neural net can represent and that a small neural net cannot represent. Because I mean, again, it's like, you know, like this is a 4-layer neural net, this is like a 2-layer neural net, and you can see like there's some differences like in the grittiness But I mean, kind of like just eyeballing it, it roughly looks the same. So I think though that like a good place to start would be kind of understanding, because like when we're fitting the small neural nets to the large neural net, we're gonna get like a average distance kind of error. And so it would be a good idea, I think, for the case of like, of course, like I need to decide if I'm going to do this in 2 dimensions, or also like really how to like run like the animation. I think maybe just have like, yeah, maybe the way the animation will work will be, so we'll have like say 5 or 6 large neural nets, and then we'll display the output layer for each of them. And then like animate the smaller neural nets fitting the larger neural nets. Like here's a good one. Like this is clearly visually distinguishable. But anyway, the point I was going to make was that it would probably be good to know, like, if you just have like purely random mappings, like what is like the expected distance between them? Because I mean that doesn't like give you like an upper bound on the distance. Like, I mean, we're literally just saying like we have 49 points in R2, and we're pairing each of those points with like randomly another point in R2. And so like what is the expected I guess like average distance, which is like, that's like a probability problem, but I don't know how to solve it. So I mean, is it like clearly the maximum distance is square root of 2, right? So, but yeah, but what we can do is just like simulate a bunch of samples and look at what the average distance is. But yeah, that doesn't. Well, yeah, I mean, I think like the upper bound, like so, like the upper bound on the distance would be like if every point, because the maximum distance you can have on the unit square is like square root of 2. So if you had like 49 points and they're all maximal distance, you would have 49 square root of 2. Yeah, maybe we'll keep that in mind. We'll keep that in mind. So we'll just yeah, so like we'll just directly implement the animation. So I think basically, okay, so I think basically we're just kind of, we're gonna have like a refresh every iteration, and so like every iteration we're going to like initialize a new population of like large neural nets, and then we'll display like their output layer, like similar to this. And then I think like for each one we'll train like a small neural net to match it. And then like we'll display the output mapping of the small neural net. And that'll be like an animation step, or like an animation frame. So it should be, like if it's going to work at all, that visually the difference between the larger neural nets and the smaller neural nets will become like visually noticeably different. You know, and then we can infer something about like the extra like representational like capacity that like a large neural net gives you over a small neural net. So yeah, so let's just do that. Okay. So guys, don't spam me. Jeez. Don't spam me, bro. I'm doing neural nets, you know? Okay, so I'm gonna do like a new new app file, JavaScript thingy. And yeah, so it's going to be like we'll just say evolving. We'll just say evolving. Because also, like, I mean, we're not really evolving, we're doing hill climbing. But it's kind of like evolving. Also, I was trying to think of a way if you could make the entire thing, like, purely differentiable. You almost kind of could, right? Like, you could... Could you, because you have, like, your grid of points. And then you'd pass it through, like, a large neural net. The thing is like, you need to have, like, a large amount of, like, small neural nets, I think. But then, like, your error would just be, you know, the distance between the output of the large neural net and the output of each of the small neural nets. That might be differentiable, but we're just gonna do it this way. So okay, so yeah, let me like write out what I'm doing. Also that way GitHub Copilot will know, so then it can just write all the code for me. Okay, so like at each, well, let's see. Okay, initialize a population of evolving creatures. That is true. That's what we're doing. Let's say like, because it needs to fit on the screen, and also my computer needs to run it. So let's say 8, right? Because like it's a good power of 2. Or should I say 4? Let's say 4 for purposes of debugging, you know. So a 4 neural networks, yeah, with random weights, with 5 layers each. Okay, and then so then I think like yes, each network has 5 layers. Each layer has 3 neurons. That is incorrect. 2 inputs, 1 output. Fitness. Okay. Calm down. Okay, so at each iteration step, yeah, I should call these large neural nets. At each iteration step, the mapping implemented by each of the large neural networks is determined, then a two-layer neural network is fitted. Is fitted a word? Like, I mean, Copilot thinks it is, so we'll just say it is. Because, like, it could be fit. Did you fit it? Right? That's a weird word. Like, I don't have any intuition on that word. So, then a two-layer neural net is fitted to the mapping. The large neural network with the highest distance to the fitted two-layer neural network is selected and mutated. Yeah. And then, like, the output layers are displayed. Nice. Nice. This is a cool app already. I've only written a comment. This looks like a really cool app, you guys. I'm just gonna stop it there. I mean, no, okay. So, like, okay, so we need the initial population. So, does this need to be a variable? Yeah, I guess it does. So, like, var large neural nets is going to be an array. And yeah, and then like const number, yeah, number of large neural nets, number of large nets equals 4. Good. Oh yeah, sure, that can be a variable too. Number of neurons. No, we don't need that to be a thing. Okay, so initialize the large neural networks, please. Yes. No, that's not how you do it, buddy. Okay, so we're gonna copy paste a little neural net action here. I think yeah, right here. And I don't need to, I'm not going to be like optimizing the large neural nets. So, whoops. Where's my thingy? Oh, like I'm still running this? Yeah. Let's not run this, because I need my CPU cycles. Guys, there's a chip shortage, so I need my cycles. Okay, so we're gonna do this sort of thing here. Const, I think you see, because like the const scopes to the for loop, doesn't it? I don't know. Okay, so we got number of layers going. So like the number of layers is like not including the input layer, as it would. So these are all 2x2, or like 2 units per layer. Okay, so that's the population of large neural nets, and then we can directly do like the animation, I believe. Oh, yeah, no, I should initialize the input grid also. Initialize the input grid. I'm also going to copy paste that. Yeah, I should do number of ticks in the grid. Whoa, it knew. That's pretty freaky. It's kind of freaky, but so yeah, cool. Very cool. So this is the input grid, which will be the input data, and that's just going to be a const. Does that matter? I have no idea. Okay, so is that all the initialization? I feel like that's all the initialization. Let's see. Oh, we need to initialize the canvases. Yeah. Need to like initialize the canvases. Okay. So for each large neural net, to draw the output of that neural net, this needs to be number of, what's it called? Number of large neural nets. Yeah. Okay, so we got all our canvases on the document. And then we're also going to copy over the draw function, which will draw. Yeah, okay, so we need the function for drawing. To draw the output of each layer. Well, of a neural net. So I think we just need to pass in the neural net and also the layer, or the canvas, and we just call neural net on the input grid, and yeah, that should work. So to test that everything's working, we're going to, well, we'll create the animation step. And yeah, we'll just draw the output of each neural net. Wow, it knew exactly what I was going to do. That is pretty creepy, man. That is pretty creepy. Oh yeah, you have to request, like, well, we're not going to request an animation frame, but okay, so we should have something drawn to the screen if I turn on my server thing. Okay, and we have nothing drawn to the screen, so why not? Activation is not defined. Wow. So we'll just define that real fast. 10H. Like nobody uses 10H anymore, but okay, so we don't have any errors, but we also don't have anything happening. Okay, we do have our canvases, and what's the difference between padding and margin? Margin, padding, border. Yeah, I think I want margin. Oh, that's what I have. Oh, cool. Okay. So, okay, so we're not drawing anything. Whoops. Why not? Why not? Draw layer. We should make that say draw, like neural net, but neural net predict. Well, I just don't know why it's not drawing anything. Okay. Draw layer. Oh, we're not calling animate. Oh no. Wow. Jeez. I got destroyed by JavaScript. Yet again. Okay, that looks cool. So yeah, so that's like our 4 large neural nets. Now they're all the same because we're all, when we're doing the initialization, it's the identity function. Okay, so that's cool. All right, so what we want to do is get the output mapping. So we're going to need something like best large neural net, right? Because we're going to have to go through them and then fit a small neural net to the output. Whoa, it knew exactly what I was going to say next. Holy. That's pretty freaky. Best large distance tolerance. I don't know what that means. So we need to go through each of the large neural nets. Do I need to index it? Yeah. Oh, and also this needs to say best large neural net. Best, we'll just say best distance. So the best distance will be large. We want to make the distances large. So we're going to figure out the output mapping of this neural net. So this is large output. I'll use camel case. Yes, that's cool. And then we're going to create a small neural net this is going to create a bunch of neural nets. This might crash my computer, but that's totally cool. So yeah, we're just gonna use like a yeah, I guess for now we'll just use like the same initialization. Okay, so this is going to be a small neural net and with 2 layers. And yeah, and then we're going to compile it using optimizer and mean squared error. Except I'm going to use Atom because it is better. Okay, so this is the small neural net, and then yeah, we're going to fit. Yeah, exactly. Fit. Yeah, it needs to go the other way, buddy. Jeez, I don't know why it seems to regularly confuse that. So yeah, so then like number of epochs, like this is something I don't know. 25. I think we're training on the entire batch. Let's make sure we're using the whole batch. I don't know what the keyword is though. Is that batch size? Yeah. Batch size is the whole batch. So number of ticks in the grid times number of ticks in the grid. Actually, we'll say squared. Right? Okay. Do you have to call await on that? Because, well, it returns a promise, so I don't know. I don't know if you have to call await. I feel like you do. Or you could say like dot then. Yeah, let's do like dot then. I'm a dot then guy. That makes sense to me. Dot then. Okay. So, oh yeah, we do need to add the small canvases. Yeah. Okay. Alright, let me add small canvases real fast. Alright, fast. For each small neural net. These are small canvases. Oh no, I don't know how to do multi-line select. I literally don't know how to do multi-line select. So like I have to type this manually. Okay, so we got all our small canvases, yeah. And then, so this thing is saying like, hey, let's draw it. Let's draw the output of a small canvas. I'm like, okay. Yeah, you could draw the large one too, I guess. Sure, if that's what you want to do. If that's what Copilot wants to do, that's what we'll do. Yeah, but you didn't do any of the evolution stuff. Okay, so you need to say, yeah. If best large neural net is null or best distance, yeah, this is exactly. This is scary, frankly, that it knows how to do all this stuff. Best large neural net is large neural net I. Best distance is all that. I don't understand why there's a index or a array index there, but and the best distance needs to be small, or like, well, we want it to be large, so if the current distance is larger than the best distance, we want to keep the thing. I don't understand why this is here. Predict large output. Subtract the small neural net, square it, take the mean, data sync. Oh, because that returns an array. Okay. Okay. Alright, so that will update. So at the end of this loop, we will now have. Also, I feel like doing this within the loop is like not the way to do it, but fit. Yeah, that needs to say neural net.fit. The heck? And then that needs to be like that. Okay, and then close that. And then, yeah, and then mutate. Is this going to mutate for me? No, okay. So we need to mutate the best large neural net and repopulate the population, which is going to involve like going through all the weights and adding noise to them. So I think we can do like for number of large neural nets, if it equals the, can you do that comparison? I don't like, yeah, that's large neural net. We just want to keep the index, I think. So then, like, if it is the best large neural net, then like we don't do anything. We'll just let it be. Else, we're gonna take the current neural net at that index and like mutate it. So so we need to get like the weights. We need to copy the weights of the best neural net, add noise to them, and then update the weights. So I think we'll go, yeah, so you go through the layers. Layer weights. So let like old weights and biases equal the current layer. So the small neural net, oh no, yeah, the large neural net. So these are the weights we're replacing, and then so we also need to get the weights for the winning. Oops. To be for best large neural net. Okay, yeah, you do need to do that every time actually, because it depends on the layer. Okay, get weights, and then so the new weights is just W plus noise. So new little weights are, yeah, except it's the big one. Okay, and then the new bias, yes, and then we just update the, yeah, set weights. Okay, so that should totally work. Oh yeah, and you never need to actually access those weights. Okay, so that should like run. It doesn't. I think my internet dropped. Plus I keep getting spams. Animate 128. Hey man, stop spamming me, dude. Jesus. Okay, why is this like not running? Large neural nets. Console.log best large neural net. Dude, am I still getting spams? Holy fuck. Jeez. Okay, so best large neural net is null. So oh yeah, I never like used the history. Ha. Yeah. We need to update best distance. Or, well, no, I mean that does update. Large output. Subtract. So console log best large neural net best distance. $127. I think it's like I don't know how to use promises. Okay, I don't know how to. Yeah, it's because I don't know. It's because I'm using like a yeah, we're getting killed by the promises. Yeah. Also, the distance just needs to say history. If we say await, it's like I don't know how to use a promise. 113. Yeah, okay, so it doesn't like that. So if we say history equals await, that's cool or not. Wait, and copy paste all of that. So this is inside. So like, okay, so you do this after that for loop. So you do the for loop and then this stuff. This needs to say async, maybe. Assignment of constant variable at 122. Yeah, I can see that. Okay. So these are the 4 large neural nets, and these are the 4 small neural nets. And okay, so that was a single frame. And so now we should call the full now some crazy stuff is going to happen. Yeah, let's output the best. So the best distance should be getting larger. And it's undefined. So that's cool. 125. Best distance is undefined. It should definitely not be undefined though. Okay. Undefined. I think it's because I don't know how to use the history object or whatever. Okay, how do you use a history object? Validation data. History. Wait, what do you say? Initial samples. It's definitely doing something. Loss. So what do you say? You say history dot, or how do you use this? So this isn't like the history or whatever? Yeah, history dot loss 0? Or does it need to be at the end? Because it goes down, doesn't it? So if I go to the history, Yeah, like it goes down. Yeah, it goes down. Yeah. So you want like the last one. Sheesh. History dot length -1. Okay. And then print the best distance. Oh my god, it's still not working. Oh my god. Why? Why? Dot loss. Dot loss. There we go. Now we're talking. Now we're talking. Now we're talking. Yeah, I don't think that's how you're like supposed to use the history thing, but that's fine. Okay, so I also well, yeah, okay, so we'll just see if this runs. To what extent, if any, does this even run? So the distance, it does seem to go down a little, doesn't it? But it also goes up. But then it goes down. Huh. Yeah, I need to like display the distance on the actual screen. But yeah, this is gonna be pretty like impossible to interpret. So I think we need more which does tend to make it slow, I have to say, but yeah, so it's like this is a random mutation, this is the fit. Yeah, I mean this is working, it's just very slow. Yeah, I need to have like a canvas on the top that displays the history time series. But I mean, like the distance is increasing. It is increasing. Just extremely slowly. We are increasing. So what if I made the variance on the noise larger? Yeah. Let's make that larger. It's increasing. It's definitely increasing. We're up to 0.1. Then we dropped. Yeah, I should, I feel like I should, implement the evolutionary algorithm better. Well, why would it drop, though? Yeah, it could be sometimes those are just, like, poor fits. You were plateauing at 0.169. But, how many ticks do we have? I guess that's 100. So if you do, square root of 2 times 100. Well, yeah, it would just be square root of 2. So square root of 2 is 1.4. Okay, so yeah, so we should be able to get higher than 0.169. We seem like we keep getting stuck at 0.169. I think what I might do next is, instead of using an evolutionary algorithm, use like human inputs, like a human manipulating the weights for like the large neural net, and then seeing if the smaller neural net can mimic it. Yeah, that'll be even cooler.